Hello class, this is just an introduction to motions. In this chapter, we will be applying and furthering our understanding of differential and integral calculus in terms of the motion of objects. More specifically, we'll be looking at simple one-dimensional motion, as we will be ignoring real-world factors such as, simple because we ignore friction, drag, wind resistance, fluid dynamics, etc. And one-dimensional because we ignore 3D motions and 3D forces such as centrifugal and centripetal forces. In higher levels of math and engineering or physics, they factor these ideas in and apply them, and along with these listed, many more factors and ideas. The first aspect we should understand is topic-specific notation and its related meaning. So, here we go. The first thing we should understand is displacement. Displacement is the distance of an object relative to where it started and which direction is forward. So I've drew so this here is a displacement time graph because x shows how far away it is from the origin, and t, usually in seconds, measures how long it's taken to get to that point. So I've drawn here a little stick figure. Here's position 1. Notice how, since this is now considered the origin, his displacement is 0. Now that he moves to the right, it took him 2 seconds to move 2 meters. So from the origin until 2 seconds, he's now at 2 meters away from the origin. From his second position, he moved to the left, which took him 4 seconds. So from 2 plus 4 seconds would be 6 seconds since the beginning. And he moved 4 meters to the left, meaning he moved 2 meters back to the origin because he would have crossed the middle point, which is the origin, and then 2 meters more. So he went across the origin and then 2 meters more. That's his third position there. Then lastly, it took him 1 second to move 2 meters to the right. So 1 more seconds, he'll be in the 7th second. And 2 meters to the right would bring him back to his original position as shown there in the graph. So displacement is measured as a distance x from the origin at a time t. You will see this as some function of t, so x of t, so the displacement at time t. It might be 2t plus 3, it might be negative 2t squared plus 4, or whatever other function of t we might see. The next aspect we should learn is velocity and speed. Both of these measure the rate of change of displacement over a change in time. Velocity considers direction as well as the change of displacement, meaning moving forward would give positive velocity and moving backward, in air quotes, is negative velocity. By that we mean if we consider throwing upwards, forward, the speed that it took to go up is positive velocity, and going downwards would be negative velocity. Speed, on the other hand, only considers positive values and total distances covered over some time, and we'll cover more on this later. So for example here, if this person in time has moved away from the origin, for them to be moving away from the origin, they must be having positive speed or positive velocity, sorry, because they're moving away from the origin. But as they move back towards the origin, right, since this is forward, this must be considered backwards, so they're going back to the origin. And we'll see later on that there's a point there in the middle that has 0 velocity, which would be a stationary point. An aspect that we should learn is that instantaneous velocity. That's very important we include this, because instantaneous velocity is the derivative of displacement. So v, velocity, is dx on dt, which is this new symbol here, x dot. This is just a topic-specific notation. The last aspect we should learn is acceleration, which is the rate of change of velocity over a change in time. Acceleration is the derivative of velocity and can be also considered as the second derivative of displacement. So A, acceleration, is the derivative of velocity with respect to time, or it's the second derivative of the displacement with the second derivative of t of time. It can also be represented as x dot or x double dot. A better understanding of the relation between displacement, velocity, and acceleration will be further developed as we progress through the topic. But just in summary, we should learn that displacement is some function x equals f of t. So for example, it might be x equals 2t plus 3, negative 4t plus 8, or even e raised t. The velocity is the derivative of, the instantaneous velocity is the derivative of the displacement. So for example, if we found the derivative of this one, we get 2. The derivative of this function, we get negative 8t. And the derivative of this is e raised t. And lastly, acceleration is the derivative of velocity, or the second derivative of displacement. So just continuing this, if we differentiate this again, we get 0. Differentiate this again, get negative 8. And the derivative of e raised t is itself. So hope that gave you a good introduction. Hope to see you in the next video. Best of luck.